And I'm going to share my screen with you all. Okay. And yesterday we started talking in our lesson about adding, subtracting, multiplying, and dividing radicals. Okay, we did some operations with radicals. You'll remember we said to add and subtract is a little bit more stringent as far as the requirements go. We had to say, you know, you got to have the same root and the same radicand in order to be able to add and subtract. Here, that's not the case. With multiplying, as I've got on my screen here with this example, with multiplying, all I have to have is the same root. And once that's the case, you know, I can multiply what's on the outside by what's on the outside, what's on the inside by what's on the inside. And that's what we're going to do here with this example. Okay. So first things first, I actually wouldn't go to the trouble of multiplying 20 times 28. You'll see why in just a second, but I will multiply 2 times 3. Ooh, let me get me a color here. We'll do blue. We'll do 2 times 3 is 6. I got 6 on the outside, and I know it's going to be a fourth root. But look what I'm going to do. I'm going to leave 20 and 28 separate, and then I got y to the 5th. We got y squared times y cubed, okay? The reason that I'm leaving 20 and 28 separate is because, well, number one, I don't feel like multiplying them, and number two, that would just make my job a little bit tougher as far as pulling out a perfect factor, okay? Since this is a fourth root, I'm going to want to pull out a fourth factor, and not a fourth factor, a perfect fourth factor here. All right, so here we go. The fourth root of, now 20 is the same thing as 2 times 2 times 5, and 28 is the same thing as 2 times 2 times 7, and then of course y to the 5th, okay? Now, I don't know if you're keeping track, but that 4 right there on the edge, sometimes I like to refer to that as, or how you can approach a problem like this, I like to refer to this as sort of using the, quote, Jailor method. I think that's an OR word, not an ER. Jailor. What do y'all think? Is that ER or OR? Somebody that works in a jail? I can't spell, so we'll go with the ER, whatever. The Jailor method, all right, it's sort of like this little 4 right here. It says, you know what, fellas, I will let you out of jail. I'll let you out of the radical as long as there are, you know, in this case, 4 of you. If it's a cube root, 3 of you. If it's a sixth root, 6 of you, that idea. So check this out. We got 1, 2, 3, 4. We'll get your booty out the door, okay? So we can take all of these 2's out, and we can say, you know what, they get out of jail. We'll write it once. There was a 6 out there already, and now what we're left with is a 5, a 7, and a y to the 5th. Kind of taking some baby steps on this problem, okay? But when we're simplifying radicals, fellas, that's all you got to do. You just got to consider, okay, what are the perfect factors that I could take out, all right? Now, perhaps the more elegant approach to that would have been to say, you know, this is the 4th root of, and then to say, well, 20 times 28 is the same thing as 4 times 35. Oh, excuse me, not 4 times 35, 8 times 35. 8 times 35, and the 4th, my kid, I'm sorry, it's not 8, it's 16. It's 16. That's 2 times 2 times 2 times 2. 16. And then 4th root of 35, 4th root of y to the 4th, and then 4th root of y. So a little bit more of an efficient approach would be to pull out those perfect factors anyway, but you can do it as however you like. 6 we got just being 6. 4th root of 16, as we said earlier, is 2. Can't do anything with 4th root of 35. 4th root of y to the 4th would be y, and not gonna, well, I can't do anything over there on that one. All right, so simplifying out your answer for this problem, 6 times 2 is 12. And it looks like we've got y and the 4th root of 35y. All right, now I want to throw a question y'all's way because hopefully somebody's going to raise a hand or has raised a hand and is saying, wait a minute, Coach Morgan, why didn't you do such and such? What do you notice that and maybe I'm speaking out of both sides of my mouth here, but what do you notice that I did not include with that y that's on the outside there? Fourth root of the y to the fourth we talked about the other day should be what?
Y.
Not y. Y'all remember going through this with me? No, man, absolute value, absolute value. We had talked about, well, yeah, there you go. There's a good example. Part C right there, absolute value of P, right? So we had talked about how if you're simplifying down a perfect fourth root of P to the fourth or a square root of X squared, you ensure non-negativity with absolute value signs, right? And yet here I am kind of talking out of the other side of my mouth saying, well, highlighted in green here, you don't really need the absolute value. So the question then becomes, well, why not? Okay, and the answer is rather subtle. The answer is because there's still a y left in the radicand. Okay, one of the things that you guys need to know is that you cannot take an even root of a negative number. Okay, so for an nth root where n is even, okay, that x being still in the radicand implies there's a domain restriction that x is non-negative. Like you're not allowed in algebra 1, for example, to take the square root of negative 36, okay? Because what number multiplied by itself would equal negative 36? It doesn't work that way, okay? And so that fact that y is still in the radicand right here is implying that y is greater than or equal to 0, and therefore I don't need absolute value signs on the outside there. That's a small, subtle difference, but it's there, and so you don't want to be redundant by putting unnecessary absolute value signs on there. Okay. Now, that's a pretty complicated example of what we've been talking about, right? I mean, you could use the Jailor approach or the Jailor method. You could count factors. You can split it up kind of as I did over here and a little bit more efficiently, just piecemeal it one perfect fourth at a time. But the idea is simplifying out radicals is the way to go. Okay. One last example, and then I've got a little activity for us here, is I want us to use FOIL. I want us to use FOIL with some radicals, okay? Look at the example I've got right here, example 5, part A. Go ahead and write this down. You got a binomial times another binomial, okay? And Jack McBee, remind us, I mentioned FOIL. What does that FOIL stand for here?
First, outer, last.
Yeah, very good. First, outer, inner, last. So first times first should be obvious. 3 times 4 is 12. Okay, when I do the outer two, I've got 3 times negative 2 square root of 7. Okay, I got 3 times negative 2 square root of 7. Now, in that case, I don't have a radical that's with that 3, so I'm just going to multiply the 3 times the negative 2. So that becomes negative 6 square root of 7. Okay. What do you think, Jake, what do you think the inner 2 will multiply to give? If I want negative 2 square root of 7 times 4, what's that going to yield?
Negative 8 square root of 7.
Very good. Negative 8 square root of 7. Again, because 4 is just a number, so we're going to multiply it by the coefficient of negative 2. And then my last times my last, this is where some students have a little bit of trouble. Okay, it's negative 2 square root of 7 times negative 2 square root of 7. All right. Do you guys remember how we did this yesterday? We said when we introduced the notion of multiplying radicals, we said you multiply what's on the outside by what's on the outside, and what's on the inside by what's on the inside. Okay. So if I multiply the outside by what's on the outside, negative 2 times negative 2 is positive 4. And then if I multiply what's on the inside by what's on the inside, 7 times 7 is 49. Square root of 49 is 7. 4 times 7 winds up being 28. Okay. Now, when we do FOIL, what do I do at the end? You know, any old FOIL problem, what do I always try to do at the end? FOIL. What do you think, Tiago?
You multiply it back out to see if you were right.
All right, so that's kind of what we did to start with, right? Okay, so like a basic FOIL problem. Let me jot one down here in blue, just real quick and easy. So like x plus 3, x plus 5, right? Like when we do FOIL for that, I got x squared plus 5x plus 3x plus 15. All right, so Tiago, what do I do at the end of that problem? Do I just leave it as those 4 terms?
You combine them.
Bingo. And which two typically go together of the FOIL?
The F and the L.
So those two? Raising an eyebrow.
The outer and the inner.
Attaboy. Typically what we see is that the OI comes together, the outer and the inner. Typically that's what we see. And in fact, that's what's going to happen over here. Okay, when we're multiplying a binomial like what we've got here, where the second term of each binomial has a square root in it, you know, the outer and the inner are both of those are square root terms. So they're going to go together. And in fact, if I consolidate them as such, that's -6 square root of 7 and -8 square root of 7, right? So Charlie, how much is that going to consolidate to equal? What do you think, Charlie?
What was the question?
Put your O and your I together. You got -6 square root of 7 and -8 square root of 7. How much is that going to tally up to be?
-14 square root of 7.
Yes, sir. Very good. -14 square root of 7. Okay, fabulous. Now, actually, from what Tiago said a moment ago, you kind of let the cat out of the bag there, Tiago, when you said the F and the L go together. And I don't know if you were just taking a guess or if you actually realized. But look here, fellas. Something that's a little bit different is that the F, which was 12, and the L, which is 28, they are going to come together as well. Okay, so our final answer on this problem is actually going to be 12 and 28 make 40. 40 minus 14 square root of 7. Okay, and what I tell people all the time, check this out, FLOI. This actually is a flowy problem instead of a FOIL problem. Flowy is what we get when we're multiplying a couple of binomials with radicals or with square roots, right? F, right? The F times the F, well, I don't need to rewrite all that. I've got it down over on the left side, so I won't confuse you by doing that. But just suffice it to say, when it looks like this, when you've got two binomials that are structured this way, try flowy, the F and the L go together, okay? Now, that being said, we're going to pause, and Tiago, you might need to mute yourself. We're going to pause. We're going to shift gears a little bit, okay? I've got pulled up a little Kahoot that we're going to work on. Okay. So what I want you guys to do when I get this refreshed on my browser here, it's going to generate a code. Y'all going to go to your website. You're going to enter the following code. We're going to practice doing what you've learned about for the last 3 days. And this is just for fun. This isn't a grade or anything. But go to kahoot.it. And once our game pin gets generated, this will load in here. So our game pin is 833-6473. All right. We'll see how you guys do on this. Go ahead and enter your name in there. And I'm going to fill up with water while y'all do this real quick. The Kahoot music has sparked a little dance party in my kitchen right now. This is Morgan and the ladies are in there getting after it. I don't know if you can see that. Having a little dance party. They do Kahoots at their school sometimes. Seven, eight, 9, 10. I think we're going to have about 11 people. Yep, there's Joey. Drew is in. There's Alex. Alex, Drew, John, Charlie. Yeah, this might be everybody. 2, 3, 5, 6, 7, 9. All right, sweet. So y'all ready to rock and roll? I would have out some pencil and paper, by the way. Okay. And we'll see how we do. So the first few you're gonna have like 30 seconds on, and they're just simplifying square roots and whatnot. So just simplifying radicals to begin with. All right, square root of 175. Got about 5 seconds. So you might need to make a guess. All right, pretty decent, pretty decent. So check this out. Square root of 175. What do I know that goes into 175? I know 25 goes in. You think $1.75, that's 7 quarters. So right, 25 times 7, square root of 25 is 5, and square root of 7 is left over. So option D right there. Okay, so pretty quick. You got to be on your toes. That's our first question. Let's see if we can get some streak bonuses going here. Looks like Jack McBee coming in first place so far. See if he can hold on to his top spot. It's going to be a long Kahoot, though, so we'll see. Square root of 50. All right, got about 5 seconds. All right, again, pretty decent, right? 50, we just got through talking about 25, goes into 50 twice. So square root of 25, square root of 2. Square root of 25 is 5, so you got 5 square root of 2. Option B looked like it would be the way to go there. All right, Charlie and Jake climbing up to the leaderboard. Question 3. We got 60 seconds for this one. This one might take you a little long. But again, it's multiple choice, so use some of the answers to help you. All right, we got about 10 seconds. All right. Now let's take a peek at this one. 112, a little bit of a bigger number, right? So what I would recommend doing is divide it by 2, okay? And what do you get when you divide it by 2? 56 maybe? No, yeah, 56. Divide 56 by 2, and you get 28. And so that means that I've got 4 times 28, pull out another 4. 4 times 4 is 16. So looks like that 4 square root of 7. 16 times 7 wound up being the way. Doing a little mental arithmetic. And if you got a calculator, of course, that makes it a lot easier on these kinds of questions. Oh, Charlotte climbing up to that top spot. All right, let's get out. Go. Very good. Very good. All right, 16 times 2. Square root of 16 is 4. 4 square root of 2 is our answer. Moving on up. Jake's rocking out with that answer streak. I like it. Somebody must have accidentally Either that or you're being a guesser trying to get lucky. Not okay, very good. You guys are getting the hang of this pretty nicely. 18's got a 9 in it. Square root of 9 is 3. Leaves a 2 on the inside. Square root of x to the 4th is x squared. So the only thing left inside is 2. No leaderboard board changes there. All right, here we go. Now, 9 is a classic example. We've seen that before. Five seconds to answer. All right, pretty good, pretty decent. 98 is 49 times 2. So we got 7 on the outside, 2 on the inside. N cubed has an n squared that we would pull out. So you got an n on the outside. Now, let me go ahead and give you a little bit of a, now that we're done with most of these simplifying questions, let me give you a little heads up on a short, quick way to check yourself, okay? So obviously, I answered C was the correct answer, okay, you know? So check this out. Look, if I take what's on the outside and I square it, okay, and then I multiply that by what's on the inside, I should get the original radicand. I don't know if you guys knew that or not. Okay, but 7n squared, 7n times 7n is 49n squared. 49n squared times 2n is going to give me 98n cubed. So that's your trick for a square root. Square what's on the outside, multiply it by the radicand, and that should give you the original radicand. All right. Okay, no leaderboard changes. All right. Now, I got to be honest with you. I thought more of us would get this right. The square root of 64 is 8. So I could throw out options A and B right off the bat. You know what I mean? Okay. Square root of 64 being 8, I know that either C or D is going to get the job done. And then it's just a matter of what's the square root of R to the 4th. And you guys remember what we said you could do with the exponent yesterday? A 4 and then a 2 out here. We could divide it by 2. We could cut it in half when it's a square root. If it's a cube root, cut it into a divide by 3. But 4 over 2 is 2, and that just leaves me with 8r squared. All right. Now, we're halfway done with this quiz, okay? And so now we're going to start getting into some operations, I believe, if I'm not mistaken. We're going to add, oh, no, we got one more simplification. Very nice, very nice. 144 was that main culprit there. Drew getting up on that top board, top
I
spot.
accidentally pressed D instead of C.
All right. Awesome. 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 72's got 36. U stays put. V to the 4th becomes V squared on the outside. So we got 6V squared on the outside, 2U on the inside. Now, I got to say, I take issue with this example because they're leaving off our absolute value. Just FYI, I think on their part. But, you know what? We won't hold it against them there. Very nice, very nice. 10 out of 10. So we've done several of these simplifying examples. I think we're going to get into some operations now. Ugh, no. Maybe I could have sworn it was the last 4 or 5. Yeah, absolutely. Here we go. Here we go. So here's where we're simplifying. We're adding and subtracting. So we have to have the same root, same index. Same radicand. Simplify each radical first, then add or subtract the. Ooh, I got a feeling we're gonna have a leaderboard shakeup. Y'all ran out of time on that one. Sorry, I didn't give you a heads up. Look, let's take a peek at this one because not very many people got this one correct, whether because of time or just making mistakes. But look, 18 is 9 and 2, so I know that. 8 is 4 and 2, so I know that. We got a coefficient out in front. We got a coefficient out in front. Okay. Square root of 9 is 3. So I got -1 times 3 times square root of 2. That's -3 square root of 2. Here, this is 3 times 2 times square root of 2. So that's 6 square root of 2. And there was a plus sign in the middle. -3 plus 6 is 3 square root of 2. Easy peasy, lemon squeezy. Okay. But it's going to take, you got to be on your toes and you got to be rolling on these to get her done inside of a minute. So here's what I would have done for that one. Sorry, I'm a little distracted for a moment. Let me hit next. Again, sorry, I got distracted. My daughter was in here. Please stop coming through here. Awesome, you guys. Well done. Well done. Luke climbing up to that top leaderboard just in the nick of time. 2 questions left. 2 questions left.
There are icicles falling off my roof, and they are scaring me for some reason. It's so sudden.
Just don't get hit by one.
Understood. Some of them are falling like right next to my window.
All right, not too shabby, you guys. Last question. See if our top 5 can hold on. PDF of the loop cut. Like it pulled. Halfway there, boys. Halfway there. All right, time is up. And again on this one, 54. We know 9 goes in 6 times. Here, 24, 4 goes in 6 times. So hence the 6 being left over. Again, don't be afraid. Use the test to help you take the test on these. 9 makes for a square root of 3. Or excuse me, makes for a 3 outside, which makes for -9. And then over here we had the 4, which makes for -2. Hence -11, square root of 6. All right, let's see how this leaderboard shook out. Joey, 3rd place. That a boy. Jake coming in strong. And Charlie pulling down that top spot. Jack McPhee, Luke coming up 4th and 5th. Well done, you guys. Nicely done. Hey, look, I really do hope y'all have a wonderful weekend. That's all I've got for you guys today. Y'all be safe, and I'm going to cut it off here and say, hey, over the weekend, if you haven't done any of our Delta Maths in a while, if you're owing me some work, get it done over the weekend. And in the meantime, live Jesus in our hearts forever.
Forever.
All right. Thanks again, guys. Y'all be safe.